All right, this is lesson 8.2, reflections. Reflections are our second type of transformation that we're learning. I do want to point out first and foremost that reflections are still considered a rigid transformation. So, for example, if I have a pre-image triangle ABC and I reflect it over this line and I get triangle A prime, B prime, C prime, those two triangles are congruent. They're the same size, same shape. Our objective for this lesson is that you'll be able to reflect points and shapes, but also you should be able to determine the reflection if I just give you an image and pre-image. So you should know first that a reflection is a flip. We're flipping it over a line. So there's like this line K is our line of reflection. Right there. Okay. It can be any line. So typically, you'll see reflections over the x-axis or the y-axis. Those are pretty important lines on our graph. But it could be other lines such as y equals x or x equals 2 or really any line we want, any y equals mx plus b that you can think of. The best way to graph the image of a reflection is to graph the pre-image, measure the distance to the line, and then find the image distance on the other side of the line. It's a little wordy, so I'm just going to break that down a bit. Taking a look at our picture here, all that means is, like, I'm just going to start at the top. Here's point C. This is a point on our pre-image, our before, what we start with. And to get to the image, the after, way over here, we just have to know our line of reflection and see how far each point is away from our image. So if C is this far away from the line of reflection, then C prime needs to be the same distance away, just in the opposite direction. Same thing for B. We take our point on our pre-image, see how far it is away from the line of reflection, and this distance in the opposite direction should be the same distance. Or same thing for point A. If it's that far away from our line of reflection, then A prime is the same distance from the line of reflection, just in the opposite direction. All right, so we have a graph here. Like we can say, let's take the point P to be maybe negative 4, 1, to be the point right here. We can reflect it over lots of different lines. It could be reflected over the x-axis, and if that were the case, then, not there. P prime should be about there, the same distance, right? Or if we were reflecting over the y-axis, then P is 4 away, so 4 in the opposite direction would be right there. We could reflect it over the line y equals x. And if that were the case, we'd see how far it is away and go that far in the opposite direction, put a point. Or the line y equals negative x, same thing. Reflect it over, put a point there. We'll use that maybe later, but for now, let's move on. This table is going to be pretty important. I don't just want to give you the rules right away, though, so we're going to fill this in. We'll come back at the end of the video and write down some rules, but I want to see if you can come up with them on your own. All right, so on page 67, here's example number 1. It's asking us to graph this pre-image over the x-axis. So pause the video if you need to get caught up to where I am. All I did was I graphed the pre-image already. I wrote down the coordinates for the pre-image, and I'm getting ready to write down the coordinates of the image. All right. I'm going to use yellow, I think, to show our line of reflection. the x-axis, everybody should know where that is. It's right here. That's our line of reflection, or you can think of it as a mirror. And each point in our pre-image, we're going to see how far it is away from the line of reflection, and then go that same distance in the opposite direction to find the point on the image. Starting with A, it's a little bit of a special case because A is on our line of reflection. It's 0 units away from the x-axis, which means A prime is also going to be 0 units away. It's going to stay where it is. A prime is going to be on the same spot as A. Now, B, I don't know, let's use purple. I guess we could use blue. There we go. B is 1 unit away from that line of reflection. If I zoom in a little bit, we can see that that's just 1 unit away there. So if we go 1 unit in the opposite direction, that'll tell us where B prime should be. That's B prime right there. Same thing, point C, it's 1, 2, 3 units away from the x-axis. So if we go 3 more units away from the x-axis, but in the opposite direction, that'll put us here. That's our C prime. All that's left to do is draw our triangle, and hopefully you can see that these triangles are really the same size and shape. They're just reflected over that mirror. Last thing I want you to do is, we forgot to write their coordinates. So the coordinates of B prime are 3, 1. Coordinates of C prime are 4, 3. And there we go. We just reflected triangle ABC over the x-axis. Let's try another example. We're given a pre-image. This time our line of reflection is the y-axis. All right. Pause the video. Go ahead and take a moment to catch up. Graph the pre-image, write down the points, and get ready to write down the points for the image. Okay, here's our line of reflection, the y-axis. You might be wondering, hey, is this okay that the triangle in the pre-image crosses the line of reflection? And the short answer is yes, it's totally fine. We'll take our point on the pre-image A and see how far is it from the line of reflection. It looks like it's 1, 2, 3, 4, 5 units away. So if we go 5 units in the opposite direction, then A prime should be right here. Let's do the same for B. B looks like it's 4 units away from the y-axis. So if we go 4 units to the right, then we know that B prime rather, should be there. And then C prime is 1 unit to the right of the y-axis. So if we keep going, 1 unit to the left would put C prime right here. Go ahead and connect your dots, draw your triangle, and sure enough, we have 2 triangles that are the same size and shape. If we write down the coordinates, we should have that the pre-image is 5, 1. B prime should be 4, -3, and C prime should be -1, 1. There we go. We just reflected the triangle over the y-axis. All right. Before we get to the last page of our notes, I've got 2 examples there that give the pre-image and the image, but ask what the line of reflection is. And in order to answer those, I want to remind everybody of the midpoint formula. So here we are at the bottom of page 67, and this is the midpoint formula, but I added some notes to it. So go ahead and copy this statement down here. That'll be really useful. We're going to say that x1, y1 is a point on the preimage. It's like A or B or C. And x2, y2 is some generic point on the image, like A prime or B prime or C prime. If we have that, then what we can do is pretty much this is like taking the average of the x coordinates, x1 plus x2 divided by 2 because there's 2 coordinates. Same thing, take the average of the y coordinates. And that midpoint is going to be on the line of reflection. We're going to use that fact to help us find the line of reflection for any reflection that we're given. Let's try that for example 3. We're going to need to do this for 2 points. We don't have to do it for all 4. I'm just going to pick A to start. I know that point A is right there. Its coordinates are 1, 2, 3, -1. And after this transformation, specifically this is a reflection, it gets sent to A prime, which is right over here at 1, -3. Right? Yep, that's right. So if I use my midpoint formula, then I can say that this point is going to be a point on the line of reflection. I'm going to take the x coordinates 3 and 1, and add them together, divide by 2. That'll get me the x coordinate of the midpoint. And I can do the same thing for the y coordinates. I'm going to take -1 and -3, add those together, which we can write like this. There we go. That point is going to be on the line of reflection, but I don't want to leave it like that. We can do some math and get some numbers here. So 3 plus 1, that's 4 over 2, and -1 minus 3, that's -4 over 2. I can divide. So really the point 2, -2, that's going to be a point on our line of reflection. I'm going to plot that on the graph now. 2, -2 is right here. And sure enough, this point looks like it's the same distance. It's right in the middle of A and A prime. Let's try it again for one more point. Doesn't matter, we can use S and S prime, T and T prime, J and J prime. I'm just going to use S. So I've got this point S here, which is located at 4, 2, and it's getting sent to S prime, which is at -2, -4. We're going to use that midpoint rule again. Midpoint rule might be something you want to put on a note card. We're going to average our x coordinates and average our y coordinates. So that point that I wrote in yellow, we can simplify that a bit. 4 minus 2 is 2. So I'll have 2 over 2 for the x coordinate. And 2 minus 4, that's -2. -2 over 2 is the y coordinate. We can divide those. So that's really 1, -1. That's another point on our line of reflection. 1, -1 is right here. And sure enough, do you see how that's the same distance from S as it is from S prime? Now, if both of those yellow dots are on our line of reflection, and you only need 2 dots to make a unique line, we're just going to connect those and extend them. And this is our line of reflection. Can you come up with an equation to represent this yellow line that goes through the origin and has a slope of -1 over 1? If you remember anything from last semester, you should. This is the line y equals -x. So, given an image, a pre-image and its image, we can use the midpoint formula to find 2 points on the line of reflection, draw the line, find our M and B if we have to, and then we can say, well, this is a reflection over this line, which in this case is the line y equals -x. All right. I want you to try that same process for example 4. Take your time, pause the video. Again, only use 2 pairs. If you want, I'll tell you. I used W and W prime, and then I and I prime. If you want, you can use S or P, does not matter. Pause the video, come back and check your work for example 4. All right. So, doing the same thing, I chose W and found the midpoint between W and W prime to be at -3, 3 right there. And then I used I and I prime, found that the midpoint was -3, -1, which is right here. The line through those 2 points is a completely vertical line. And vertical lines aren't in y equals mx plus b form because their slope is undefined. Vertical lines are just x equals a constant. So our line of reflection is x equals -3. And we have reached the end of our video, but like I said earlier, I want you to see if you can come up with these rules on your own. You might not, and that's okay. But for a reflection over the x-axis, we saw that in example 1. And do you notice when we reflected each of these points over the x-axis, the x-coordinate stayed the same? But what happened to the y-coordinate? They didn't quite stay the same. They just changed sign. They became the opposite. Like 0 stayed the same, but -1 switched to +1, -3 switched to +3. So in general, any point you want to reflect over the x-axis, we're going to take x, y, and it's going to switch to x, comma, -y. This doesn't necessarily mean negative. It means the opposite of y. So if y is already negative, it might switch to positive. I don't really have any abbreviations for this one, sorry. Let's take a look at a reflection over the y-axis. We saw that in example 2. Again, we reflected over the y-axis, and this time, all the y-coordinates stayed the same, right? But the x-coordinates changed. They look very similar. They just changed their sign. -5 became +5, and so on. So we'll have a similar rule here. We're just going to change the sign of the x-coordinate if we're reflecting over the y-axis. The y-coordinate will stay the same. All right. The next two are a little bit harder to see the pattern, but we can do it. In example 3, now that we did the work, we saw we're reflecting over the line y equals -x. So in hindsight, what happened? Do you see any pattern between A and A prime? And does that pattern also hold to get from S to S prime? The x and y coordinates, we had a 3 in the x coordinate here, and now there's like a -3, but it's in the y coordinate. We had a 1 here, and there's a 1, but it's positive now. So what's going to end up happening is the x and y coordinates are going to swap, and they're going to change sign if we're reflecting over the line y equals -x. So our point x comma y, when reflected over the line y equals -x, those coordinates will switch places and change signs. So we'll have the opposite of y as the new x coordinate and the opposite of x as the new y coordinate. And finally, reflect over the line y equals x. Let's do that here. I've got p at -4 comma -1, and let's reflect it over the line y equals x. So this is the line with a slope of 1 that passes through the origin. The distance from P to this yellow line, we need the perpendicular, just the shortest distance possible here. It looks like it's like 1 diagonal, 2 diagonals, and then half of a diagonal, right? Let's do that over here. We'll go half of a diagonal first, and then one more, and our second diagonal. We've got P prime right here, and that's at the coordinates 1 comma -4. And sure enough, we have a similar pattern where they're switching, but it looks like they don't change signs. -4 stay to -4, 1 state of 1, we're just switching. This is not a proof, but you can try it for any point you want. It does hold. So the last rule we're going to add here is that if we're reflecting over the line y equals x, then x comma y will be mapped to y comma x. These rules are pretty important. Probably want to write them down in a note card. That's the end of the video. As always, ask a question or make up your own, and I'll see you all in class.